Hi, I'm Tovia Merenstein, and I'm going to be teaching you how to do Law of Sines and Law of Cosines.
Law of sines and law of cosines allow one to find angles and sides of triangles when a right angle is not present in the triangle. Therefore, you cannot use the Pythagorean theorem or SOHCAHTOA. First, we will start with law of sines. The law of sines reads, sine of A over A equals sine of B over B equals sine of C over C. The law of sines can be applied if you know a side and the angle opposite it. Then you can use the law of sines to determine the other angles or sides in a triangle, given one more side or one more angle. Law of sines is applied in angle-angle-side cases, angle-side-angle cases, or angle-side-side cases. Now we will discuss law of cosines. Law of cosines states c squared equals a squared plus b squared minus 2ab cos of c. Law of cosines is used in side-side-side or side-angle-side cases, where c is the angle you are looking for in side-side-side cases or the angle you know in side-angle-side cases. We will begin with the law of cosines example. This example will utilize a side-angle-side triangle where we have two sides and one angle in between them. In triangle TOV, find side T. We will begin by writing the law of cosines formula, which states that c squared equals a squared plus b squared minus 2ab cos c. When we fill in our values, we get c squared equals 3 squared plus 4 squared minus 2 times 3 times 4 cos 30. As we solve it algebraically, we find that c squared equals 9 plus 16 because 3 squared plus 4 squared equals 9 plus 16 minus 24 because 2 times 3 times 4 is 24 cos of 30. Then c squared equals 25 minus 24 as we add 9 and 16 together, cos 30. C squared equals 25 minus 20.7 because cos of 30 times 24 is 20.7, and c squared equals 4.2. You must take the radical of 4.2 in order to isolate c, and you are left with c equals 2.05. Next, we will look at a side-side-side case for law of cosines. In triangle CAT, find angle C. Again, we will begin by writing out the law of cosines. C squared equals a squared plus b squared minus 2ab cos c. Then we will fill in our values. 10 squared equals 6 squared plus 5 squared minus 2 times 6 times 5 cos c. As you begin to solve it algebraically, you find that 100 equals 36 plus 25 minus 60 cos c, because 10 squared is 100, 6 squared is 36, 5 squared is 25, and 2 times 6 times 5 is 60. Then 100 equals 61 because 36 plus 25 is 61 minus 60 cos c. Because you are trying to isolate side C in order to find it, you must move the 61 to the other side. In order to do this, you subtract 61 from 100, getting 39 equals negative 60 cos c. In order to isolate the cosine of c, you must divide both sides by negative 60. You then get that 39 over negative 60 equals cosine of c. You must inverse cosine of c in order to isolate c, and what you do to one side you must do to the other. Therefore, you take the cosine inverse of 39 over negative 60 equals c. You will then find, when you plug this into your calculator, that c equals 130.5 degrees. Next, we will do a law of sines example. In triangle PBL, find angle B. This triangle is an example of an angle side side triangle because we are given an angle and two sides. We will begin by writing out the law of sines. Then we will fill in our corresponding values according to our triangle. So sine b over 16 equals sine of 40 over 13. Because there is an equal sign in between the two fractions, you can diagonally move any term. So, if you move 16 diagonally, you get sine b equals sine of 40 times 16 over 13. By plugging this into your calculator, you will find that angle B equals 52.29. For some triangles, there can be more than one answer. This occurs because a triangle can lie in quadrant 2, quadrant 3, or quadrant 4 as opposed to simply in quadrant 1. In this example, the triangle can lie in quadrant 1 or in quadrant 2. If the triangle lies in quadrant 1, its reference angle is simply 52.29. However, if the triangle lies in quadrant 2, to find the reference angle, you must use the equation 180 minus the angle. Therefore, the reference angle would be 128 degrees. Our next example is another law of sines example. In triangle CAR, find side A. We will begin by writing out the law of sines. Sine of A over A equals sine of B over B equals sine of C over C. Next, we will write in the corresponding values for our equation. Sine of 25 over 14 equals sine of 75 over A. Because you can move any term diagonally, we will move sine of 75 diagonally in order to isolate A. Then, because we can move any term diagonally, we will move sine of 75 diagonally, getting sine of 25 over sine of 75 times 14 equals A. Solving this in our calculators, we will find that side A equals approximately 32. For our next problem, we will do another law of sines example. In triangle JEF, find angle E. We will begin by again writing out the law of sines. Sine of A over A equals sine of B over B equals sine of C over C. Then we fill in our corresponding values. Sine of 26 over 10 equals sine of B over 24. We can then move 24 diagonally, and we get sine of 26 times 24 over 10 equals sine of B. If you solve this on your calculator, you will find that the sine of B is greater than 1. It is approximately 1.5. You cannot have a sine of a number that is bigger than 1, therefore, this triangle is undefined.